Hello and welcome to the Ruskin Wednesday webinar series. Today's program is primarily introducing our brand new product. We've got the AIQ TD50c or TD50, and I'll explain what that is as we go along. So as I mentioned before, and possibly you didn't hear, but would like you to please type in any questions you've got during the presentation, and we'll get to as many of them as we can as we approach the end of the presentation for you. So again, appreciate you being here today. I think I've already said this, but yeah, please actively participate by using your keyboards there to type in questions. My name is Glenn Esser. I'm an electrical engineer here for Ruskin. I've been responsible for Ruskin's air measurement products since about 2006, providing technical support for our field service group. I'm also a member of the review committee reviewing AMCA 600-16, the application manual for air measurement stations, and AMCA 611-15, the certified ratings program. So very happy to be a member of that committee to help move the science forward. Our commitment to you today is we're not going to waste your time. We've got a great new product, and you'll learn things you didn't know, I hope. We really appreciate you making time in your busy schedules to join us. And I want to keep it short but informative, so you might get a little bit of your day back here at the end. We're selling a boatload of TDP05K Advanced Thermal Dispersion Air Measurement System, and it's quickly becoming our top-selling air measurement device. I want to review the top features of the product that have made it the most specifiable product and the #1 choice for building design engineers and building owners. Ruskin's been making air measurement equipment and air measurement products since 1994. We introduced the TDP05K Advanced Thermal Dispersion System last year, and what's new this year is the AIQ series, combining our top-selling air measurement probes with the very best control dampers in the industry. In particular, we're excited to tell you about our new AIQ TD50 and AIQ TD50c as the first product in this series. Ruskin has been combining dampers in sleeves to make the most reliable fire life safety products on the market today. And from that, it's really only a small step to combine air measurement with our top-selling CD50 control dampers. Dampers with modulating actuators that are easily controlled directly by the building automation system. If you take the Airflow IQ and add the Ruskin air measurement actuator, we get all the features of the TDP05K with the Class 1A low leak CD50 damper, and we add a BACnet interface that is making it possible to interface this device now with your building automation system. The value of this product is that it's fully factory assembled as a complete assembly. We do a lot of the preliminary wiring of the actuator to the air measurement station and provide you a junction box to make your single point connections. And then it's ready to be field configured by the installing contractor. I think you'll find this to be really impressive. We welcome your orders for the new AIQ TD50. And again, the first of the series is our all aluminum product. This is exactly what you've been asking for from Ruskin, and we're happy to bring it to you. Just to review briefly, the TDP05K eliminates the transmitter box. We no longer have any proprietary cabling or Cat5 cables. We've got a system now with the highest sensor count available in the industry, with up to 16 probes and 128 sensors. The TDP05K comes standard with BACnet interface, and this network interface has 2 analog outputs reporting average temperature and average flow from all the sensors on the probes and all the probes. The TDP05K surface mount thermistors have the lowest energy consumption on the market, and it's the most reliable temperature and air measurement sensors with unsurpassed out-of-the-box accuracy, and comes complete with a full 5-year warranty. The TDP05K has two 4 to 20 milliamp analog outputs that can be individually configured for velocity or temperature. The BACnet network interface is standard and facilitates direct connection of the air measurement station by itself directly to an automation system. The airfoil-shaped probes are acid-etched and anodized, and the thermistor sensors are designed to withstand wet or harsh environments without deterioration. No transmitter box. The probes are networked together. We go with simple 2-conductor twisted pair wire from probe to probe using Phoenix-type connectors for both the power and the network communication between the probes and the primary probe. No longer are we wiring probes back to a transmitter box. But as an available option with this product, we have remote user interface. The most common remote option is a remote wired primary, which places the primary up to 500 feet away instead of on the end of the probe. The primary is always the automation interface and is normally located on the end of the probe. If there's more than one probe, it would be the first probe in the set, and that's our standard, which is the least expensive option when ordering this air measurement station. And when the air measurement station can be easily accessible on the side of an air handling unit, for example, where you can just walk up and look at it, that's really your best bet. The picture here is showing exactly that. Primary probe with display, daisy chain wired to ancillary probes, and again, there is no transmitter box. The primary probe is both the user interface and the building automation interface. What this is showing is our least expensive remote option, which is a remote wired primary. And here we just take the primary, which you previously saw on the end of the probe, we take it off the probe and provide it as a separate part. This remote then allows you to mount the primary, which is shipped separately, up to 500 feet away from the air measurement station. And again, we just use a simple twisted pair to go from the air measurement station to the remote located primary. So now, in place of the transmitter box just being 10 feet away or a maximum of 50 feet away, we can actually put that automation interface and user interface up to 500 feet away from the air measurement station. So these features are what has made the TDP05K an industry leader already. The new Airflow IQ series combines Ruskin's top-selling products into a single assembly. The product is not that different, as I mentioned, from a fire smoke damper, but now we have an air measurement station with a damper in a sleeve, and our initial product offering is our AIQ TD50. It combines the CD50 Class 1A low leak damper, parallel blade damper, in a 15-inch aluminum sleeve with the TDP05K. This would be equal to, but is much better than, the Tron Tamko products that you may be familiar with. Available to start with, we'll be offering this in single sections, a 1x1 damper assembly, if you will. That means the size is a minimum of 12 by 12, all the way up to 60 inches wide by 72 inches high. So that means we can accommodate a max here of 30 square feet. Historically, this covers nearly 90% of all air measurement stations that we've provided in the past. So again, that single size covers most of the market. So you would typically have a sleeve that's undersized by 1/4 inch for slip fit into existing ductwork. The direction of airflow is always through the air measurement section first and then out through the control damper. It will not work the other way unless it's a two-position damper, just open or closed. But air measurement is typically done to provide control of that airflow, and so it's usually a modulating damper. As an option, we can add any brand modulating actuator and have that installed at the factory, or the contractor can provide and install the actuator of their choice. The AIQ TD50, as I mentioned, is the first in this series. As we roll it out, it will be available in the future with any Ruskin control damper similarly configured. Our next product, for example, will be the AIQ TD60 in a galvanized steel sleeve. Again, this product is made in Parsons, Kansas, and air measurement is in close proximity with the damper. The damper is always a parallel blade damper for air measurement applications. This is a photo of what we were showing at the ASHRAE show this year. It's, again, air measurement in a sleeve with a control damper. We have all the features of the TDP05K plus the features of the CD50 control damper in this sleeve available with or without an actuator. In this configuration, the automation system reads the air measurement from the TDP05K and then controls the damper actuator to maintain the desired airflow. This is called controls by others. Any brand actuator can be included as an option and supplied by Ruskin, factory mounted prior to shipment. When we add the C on the end of the model number, so here we have the AIQ TD50c, we add the Ruskin air measurement actuator. The air measurement actuator was developed specifically for Ruskin and provides air measurement and control similar to our AIQ50X. This replaces our EAMS 050 and our EAMS 060, and it will eventually replace our AMS 070V controller on the AMS 050 product. So that was a lot of spelling for you, but basically we had models in the past that included air measurement with controls, and we're saying that this is the new product and it will replace and provide you air measurement with control, but no longer do you have a control box, you just simply have an actuator, and that actuator has the controls built into it. So that's what the TD50C does for us. With the C, we're adding this air measurement actuator. And it doesn't require, again, there is not a separate controller. The set point controller is built into the actuator, and it interfaces directly with the building automation system. It has two operating modes. Flow control is CFM set point. The controller, the built-in controller utilizes internal PI control loop, proportion integration control loop, and it's fast and precise. And that's via the BACnet interface. Using the BACnet interface, you can toggle from flow control to direct position control. And direct position control just allows you to command the damper full open or full closed or to any position really that you're looking for in place of providing it a CFM set point. So our normal mode is flow control, and we're looking for a CFM set point. The position control would be used for building purge operations and to drive the damper closed when the fans are off or when the building is unoccupied. It becomes a BACnet interface position control damper via BACnet MSTP or BACnet IP interface. So we can work with either version of BACnet. Those of you that were at our booth this year in Chicago at the ASHRAE show got to see this setup screen in person. The actuator has got a web server built into it. And so you access the web server by simply plugging an Ethernet cable directly into the actuator, and then with any laptop using Google Chrome, you can log on to the server. And the installing contractor uses this setup screen to configure the air measurement station for the installed system and to configure the automation system for talk to this particular actuator. So you're able to set the baud rate, device instance, MAC address is all configurable on the actuator, and that's done in the field. So what we're looking at here is the IP address at the top. It would log on using, in this case, 192.168.0.10:8080, and that puts us right into the actuator. And then the login is admin and RUSNIMDA. Now, you're not all writing this down, but it's in the instruction manuals as well that will come with the product. And this is the screen that will come up is what you'll see as soon as you log on to it. So the things that have to be configured is the square footage of the damper that we're dealing with. So, for example, if you had a 2 square foot damper, you would put in 2 square feet, and if the maximum airflow that you anticipated seeing from the unit was 2400 CFM, you'd put in 2400 CFM, and then you would toggle it to flow control. So it's pretty straightforward. What we've done at the factory is we've wired sensor input 1 to the airflow output from the TDP05K. So what's coming in on sensor input 1 is the airflow measurement. And the next step is to configure the device for the maximum airflow expected. The factory default, if left unchanged, will be 5,000 feet a minute. That means that at 100% output from the TDP05K, you'd get 5,000 times 2, or 10,000 CFM in this case. And but if you've reconfigured the TDP05K and set it so that the max airflow that you expect is closer to 1,200 feet a minute, then your max airflow would be 2,400 CFM. That's just simply 2 times 1,200 feet a minute. So again, you'll get a lot better air measurement resolution by changing it from the factory default. But again, totally welcome to leave it at the factory default as well. So pretty easy in terms of how that goes. The next thing that you set is sensor type selection. This actuator is capable of interfacing with any of our air measurement devices. And so for interfacing it with the TDP05K, you have to select EA for electronic air measurement. That's our EA series, comes up in this box here. And that's a pull-down box on the screen when they're configuring it. That allows it to do electronic air measurement. And then the last thing that has to be done is with the airflow set at 0 flow, you will see displayed up in here the actual voltage that the air measurement device is producing at 0 flow, and so you then set the 0 signal. So in this case, you're seeing that the 0 signal is almost half a volt, and so that is where, from this point forward, 0 airflow measurement is created anytime we have 0.45 volts, and then anything more than that becomes our measured airflow rate. So that's how you scale it and get it configured to accurately represent this information. So now what we've done by configuring the actuator is we've put all this information into the actuator, and now the actuator can put all of that information out onto the network via a BACnet interface. But this really completes the setup of the actuator. Those are the steps that have to be done to configure the air measurement station. The actuator, by the way, has built-in data logging. It will log for 30 days or 6 months, depending on whether you pick compressed or non-compressed data logging. But this data logging lives inside of the actuator, and so you just come up to the actuator, plug in your laptop, and you're able to download this information directly from the actuator as a Excel spreadsheet, and then take it back to your office for analysis. But things that we're seeing here in this trending, it shows us what our set point position was, what the feedback position was from the actuator in terms of percent commanded. It shows the airflow CFM, shows the airflow velocity, it shows the airflow CFM set point, and it also, not applicable here, but would show the velocity pressure that we were getting. So all of that information is logged, and you really don't have to do much more than that. As I mentioned, the information, all of that information, these 12 data points are what is now output dynamically onto the building automation system. So you're able to read these points and to command a CFM set point. You're able to toggle it from flow control to position control. And again, just a wealth of information that is coming right out of this actuator, including damper position, airflow measurement, air velocity. All of that is right here, and then you just simply command it via your automation system. Anyhow, really excited to be offering this product, air measurement and control, in one setup here. And going to pause for a minute. I've covered a lot of information. Actually, I've covered everything that I wanted to cover today in terms of what this product has and the features that it has. And we'll open up the microphone to at least my coworker here, Bill. Bill Millard, are you on the line with me, I hope?
Here I am.
Here. All right, Bill. Have we got any questions? Have I done a good job of going through all of this, or what did I leave out?
I'm going through it. Can you hear me okay?
Yes, absolutely, I can.
Okay. Yeah, Mike had a question early in the presentation. He said, is the AIQ TD50 available in opposed blade?
And good question. And what I explained is that when the damper is in such close proximity with the air measurement, again, we made this as short as possible. It's only 15 inches from air entering to air exiting. And so our damper is less than or exactly 6 inches in front of the damper. And for air measurement applications, we get the best performance with a parallel blade damper. It's been our experience that in certain conditions, an opposed blade damper can have an effect upstream of the damper, especially when a significant pressure drop is taking place upstream of the damper. The parallel blade damper can still be used to modulate the airflow, but does not have nearly the disturbing effect on the air measurement. So the short answer would have been no, it's only a parallel blade. The long answer there is why we're doing this is because air measurement works best with a parallel blade damper.
Okay, and we had another question. You've talked about the CD50 can this device be bought with other dampers?
So initially, our product offering is the all-aluminum CD50 damper in a sleeve, in an aluminum sleeve, with as the AIQ TD50. Our next product down the road will be the TD60, and we'll proceed eventually having all Ruskin's top-selling dampers, including the TED50, CD40, will be options available for combinations like this. But for today and for the foreseeable future, until you see our next announcement, it's an all-aluminum product only, and we'll be offering this combination right now as all aluminum with the CD50 damper aluminum sleeve.
Okay, next question is, when is the AIQ TD50c available to order as a sample?
It's available for sale today. We've got this product is actually been sold quite a few of them so far since the ASHRAE show. The things that we're working on is to complete some internal setup in our systems, but there's nothing to prevent you getting quotes from your Ruskin representatives today, and they'll of course be contacting us, but we're working towards rolling that out through all of our channels so that you'll be available. But for now, it's going to be the aluminum product only, but it's available today.
Okay, next question. When will this be added to Edge?
So for those of you not familiar with what Edge is, that's a question from one of our Ruskin sales representatives, and he's asking when will it be in our pricing program. And so we anticipate that to be done by today is what our goal was, but obviously we're running a little behind on that. So again, we're working on getting that work done probably within the next 2 to 3 weeks maximum.
Okay, next question. Is there a comparison chart versus Ebtron? How can we compare? How can anyone compare to our product, Glenn?
Yeah. As I mentioned as part of the presentation, this product that we're dealing with here is you could find it as a Tron Tamko marriage, where you have two companies who are combining their products. What I'm pointing out here is that Ruskin has been making dampers in sleeves for many, many years. We really don't have to go to anyone else to have the best damper on the market today. And so this product with the TDP05K would be similar to theirs. Of course, our product has numerous other features that I've elaborated on, but for example, NEMA 4 is an option, a remote up to 500 feet away versus just a simple 50 feet away, sensors that are lowest power consumption in the industry, less than 8 VA for 2 probes with 8 sensors is again lower power than what anyone is able to do. The smaller thermistors collect less dirt, and the lower power consumption means that we've gone away from having a self-heating issue, and now the temperature reported on the TDP05K is one of the calibration points that we do during the calibration process. So very, very accurate temperature, extremely excellent performance from an air measurement standpoint, and really the best combination thermal dispersion sensor out there on the market today.
Okay, next question is a two-part question. Can it be mounted downstream of a louver? And the second part is with an equalizing grid.
Not sure what the equalizing grid is. I can kind of imagine a screen of some sort that redistributes the airflow across it. Downstream from any fixed blade louver is not a problem. Actually, our standoff mounting brackets are intended to allow you to mount it either on the face of a damper or on the back side of a louver. So we certainly have that capability within our product to be directly downstream from a louver or upstream from the damper with the standoff brackets that we're providing. The main concern that you have when you're mounting it behind the louver, though, is to be aware of what your low velocity requirements are. Prevailing wind speeds are generally 8 to 9 miles an hour, and just being behind that louver, you'll still get quite a bit of air movement, and the thermal dispersion technology is so very, very sensitive that we can read down to 0. And so what that means is that even with the dampers behind the louver potentially closed, you'll still have a significant amount of air movement potentially that could be perceived as air going in, when in actuality it's just moving around. So again, thermal dispersion doesn't have to see the air going in, it just needs to see the air going through it in either direction, and it will register then.
Okay, next question we have is, which you've addressed a little bit earlier, but if you can expand on this, why are sensors upstream of the damper instead of downstream?
So the positioning of the sensors is always upstream of the dampers because the sensors are picking up a velocity profile in the ductwork. We've done our best to position the sensors in the airstream, and then we average all of those points together in order to come up with what the total airflow is through the duct. Now, the issue when you're downstream from a damper is that as that damper closes down, depending on where the sensors are located relative to the damper blades, we can either be seeing absolutely no airflow blocked behind the blade, or we can be seeing very, very high airflows as the blade closes down and the little bit of air that's slipping through is slipping through at a very high velocity. So again, your average reading at this point is just all messed up. So air measurement always takes place upstream of any modulating damper so that we can get that best reading.
Okay, we welcome any other questions. Those are all the questions we have at this point in time, but if anybody else has any, please go to the question box, type it in, and we will answer it.
Well, actually, the pretty much wraps up our presentation that I wanted to cover, and if you just email us also, we'll certainly be getting back to you. So mentioned here how to, in my summary for our reps, that they can price this in edge by selecting a CD50 damper, 15-inch sleeve, and adding then either the modulating actuator of their choice or the VAFB24 BAC air measurement actuator. So those are the steps that our reps will go through to come up with this pricing, or they'll be contacting us directly. The options, of course, that are available: the NEMA 4 option, the optional remote wired primary, which allows us to move it up to 500 feet away. So pretty neat in terms of how this works. That I think concludes my presentation for today. That's everything that I wanted to cover for you. So I want to thank everyone for your time today. Hope you found this extremely useful, and if you didn't, please let us know what we can do better next time, and we'll certainly do everything we can to improve on this series. Speaking of the series, the next webinar will be May 9th. Its topic is sealing fire dampers, and this webinar will be available at our YouTube site. And again, appreciate your time today. That concludes the webinar. Yes, sir?
One more thing. Would you tell them about, we're in the process of putting our literature and information up on our website.
Okay. Again, including, along with this webinar going up on the website, the product data sheet, the installation manual, the 3-part CSI specification, the explanation of the product that I made at the ASHRAE show. All of that will be posted to our website shortly. Thank you, Bill. All right, then. That concludes today's presentation. Again, thank you all for your time. Thank you for selling Ruskin. Thank you for using Ruskin.